Yay, more trig identities. Okay, we're getting into a gray area here. One part of the new Common Core curriculum says this is covered, and another part says it's not covered. We're covering it just in case. Here's the good part. You used to get these on your Algebra 2 regions on your reference page. So again, I don't know what they're going to do, but I don't want to skip them. So we're not even going to take the time to derive them, where they came from. We used to have a little jingle to help us remember them. We put them in this order because it would go sine, cosine, cosine, sine, sine, cosine, cosine, sine, cosine, cosine, sine, sine, cosine, cosine, sine, sine. Because back in the day, we used to have to memorize them. And then we remembered that the sign was the same. So a plus b had a plus sign in the middle. A minus b had a minus in the middle. And cosine is the complement to sine, which we remembered as the reverse. If it was a plus, it was a minus. If it was a minus, then it was plus. And this little ditty you can pay respects to a Miss Melanie Stafford, who is a senior at Springfield. And she was the one who came up with sine, cosine, cosine, sine, sine, cosine, cosine, sine, cosine, cosine, sine, sine, cosine, cosine, sine, sine. Yeah, we ran out of ditties for tangent. So, where do we use these lovely things? They help us find the exact values of numbers that aren't on the unit circle, but can be made from numbers on the unit circle. For example, the cosine of 75. We don't know that because if we go back to our unit circle and we do our branches, we know that we have 30, 45, and 60. And then we jump up to 90. We don't have 75, but we see that we can rewrite the cosine of 75 as a cosine of 45 plus the cosine of 30. And if we go back to our ditty, sine, cosine, cosine, sine, sine, cosine, cosine, sine, cosine, cosine, sine, sine. Oh, so it went cosine, cosine, sine, sine. And cosine is the complement to sine, where sine is the same. There must have been a minus in there. And then it's very easy to do. All right, the cosine of 45, well, that's radical 2 over 2 times the cosine of 30 is radical 3 over 2. Sine of 45 is radical 2 over 2. The sine of 30 is 1/2. Now, just remember your algebra. We have to multiply before we subtract, order of operations. So this becomes radical 6 over 4 minus radical 2 over 4. And now, since we are indeed subtracting fractions, we must have common denominators. Well, thank you, Lord, there are. And this is our final exact answer for the cosine of 75. And just to try one more, let's try the tangent of 165. So over here I have a better unit circle, and all I want to do is find out which one of these angles can get me 165. Well, I see that if I take 45 and 120, that will get me 165. All right, so the tangent of 165 can be rewritten as the tangent of 120 plus the tangent, plus 45. And now I'm just going to apply the formula. The formula says take the tangent of the first angle, add on to it the tangent of the second angle, and divide that by 1 minus the product of those two angles. So I'm going to take a side step over here, and it's a little harder because they haven't given me the tangent. As you can see here, they give me the cosine and the sine. So the tangent of 45 is sine over cosine. Well, that's beautiful. Radical 2 over 2 divided by itself means the tangent here of 45 is 1. We like that number. Over here with 120, well, that would be the sine, which is radical 3 over 2, divided by the cosine, which is negative 1/2. Okay, the 2's cancel out, so the tangent of 120 is negative radical 3. Okay, so now that I have those numbers, I'm just going to enter them into my problem down here. The tangent of 120, we just saw, was negative radical 3. The tangent of 45 was 1. Below we have 1 minus the product. All right, let's do some math here. Negative radical 3 plus 1 over 1 plus, because negative times negative is positive, radical 3. But realize we can't leave this as an answer. We have to rationalize this. So I'm going to multiply by the conjugate. If you remember, the conjugate means that we take the denominator and change just the middle sign. All right, so that means we're going to have to double distribute. Negative radical 3 times 1, negative radical 3, negative radical 3 times negative radical 3 is plus 3. And then distribute 1. Well, when I multiply anything by 1, that's easy. It just becomes itself, so plus 1 minus radical 3. And on the bottom, remember when we rationalize by multiplying by the conjugate, the middle falls out. So we're left with the front term, which is 1 times 1, and the backdoor term, which is radical 3 times negative radical 3, which becomes minus 3. So this finally boils down to my answer of 3 plus 1 is 4, minus radical 3 and minus radical 3 is minus 2 radical 3 over negative 2. Well, wait a second, we're still not done because we can divide out here and we can get negative 2 plus radical 3. Now, just to show you, I'm going to take out the calculator. And let's see, my mode is in degree, good. I'm going to take the tangent of 165, and this will give me a decimal approximation. But look what negative 2 plus radical 3 is. The same answer. Hope you watched this video. Too bad if you didn't.